on this computer. Alrighty, so we're recording. Hi everyone, welcome to the first ANSYS workshop tutorial. Today we'll be running down just how to download ANSYS and also give you a very basic rundown of how the program looks and how to use it. So first, I just wanted to show my web browser so that I can help you download it if you haven't already. So all you have to do, go to Google, search up ANSYS Student Download. You're going to hit this first link right here to ansys.com. And then this will lead you to this web page. You're going to go to this one, ANSYS Student. You're going to click here. And then you hit this to download it. You hit agree and download. And then you'll get this zip file. It's going to take me 6 hours to download it, so I'm not going to do that. But in essence, what's going to happen is you're going to get this zip file. You're going to want to unzip it using 7-zip or WinRAR, whatever you prefer. And then from there, you'll be able to run an executable so that you can download the software onto your computer. And if you have any trouble trying to download it, it doesn't work, or you can't quite, make File Explorer work with you, you can ask me and I'll help you get the download together. And other than that, you just give it the time it needs and you'll be able to use ANSYS. So we're going to get away from that and we're going to actually look at ANSYS. I'm going to make a very basic flow through a pipe. So when you download ANSYS, to open this, you're going to go to your search bar and you're going to type in workbench. You let that open up and you're going to see this. And you're going to have an unsafe project dash workbench. This is what we're going to use. You see a bunch of options for different things that you can use, but you don't want to use any of them except for Fluent. This is the one that we are going to learn throughout the classes and the only one we will be using. So when you hit Fluent, this is going to appear in the project schematic area. And the first thing you're going to want to, well, let me explain this. This essentially shows the steps they have to take to make the flow. So, first you made Fluent, now you're going to make the geometry, mesh, set it up, and you get your results. And I'm going to go through each one of these steps to show you how to use Fluent. So first we do the geometry, setting up the area that we're actually going to compute the flow over. So for this, you're not going to want to double click it. You're going to want to right click it, and then you're going to hit Design Modeler. If you double click it, you're going to go to Space Claim, and that's not commonly used. It's not as intuitive. So you're just going to left click Design Modeler Geometry right here. And then it's going to start the Design Modeler so that we can actually make the geometry that we're going to compute over. All right, now I'm going to switch over so that you can see Design Modeler. All right, you guys can see it, right?
Yes, yes.
All righty. So this is Design Modeler. This is how you're going to make your geometries. Oh, see the chat? Yes, good. Alrighty, so first you're going to hit Z. This is essentially going to reorient your axis so that you're looking at the XY plane. You can do either Y or X, but I just prefer to use Z here. It's just what I'm used to. What I did now, you see here's modeling. You're going to click on this part, sketching. And you're going to get a bunch of options to actually draw out objects. So you see you have line, tangent line, and all these things. I'm going to go ahead and make a rectangle because today we're just going to make a basic pipe flow, and I'll show you how. So after selecting rectangle, you'll get this little pencil. You're going to go on the blue marker, which is the origin here. You're going to hold down left click, and you're just going to drag. And this is going to automatically make your rectangle. So there, once you let go, a rectangle is generated with whatever dimensions that you have. So now we're going to want to dimension the rectangle so that we have a particular length and height for it. So you're going to go over here to dimensions, click on it, and you'll see a lot of options. General pretty much figures out what you're trying to do based on what you select. So let's say if I have general and I select this horizontal line, it'll automatically know, oh, okay, I'm trying to dimension a horizontal line. I click on it, you get this, click again, and it'll create the dimension here. So now we know that this line here is 22.747 meters. I'm going to do that again. Just click on the vertical part here for the vertical line, and that's 3.95-ish meters. So now what we're going to do is we can actually click here it's going to select the entire dimension, and we can change it. So for the horizontal line, I'm going to make this 100 meters. And for the vertical line, I'm just going to make this 1 meter. Now, the reason that I'm doing this is because when you're doing a pipe flow, you typically want your length to be much larger than your height, just to allow the flow to develop properly. And I'll show you what that means in a second. So with this 1 meter by 100 meter rectangle here, we've made the shape. Now what we have to do is we have to generate a surface. And that surface is essentially where the flow is going to be. So what you do is you're going to hit concept on the top left here. You're going to hit surfaces from sketches. You're going to click on any one line on your design here. You're going to hit apply. And that will essentially select the entire region that you are trying to make the surface over. And then you will hit generate. Then what this does, you can see now it's filled. This is where the fluid is going to be. So that the computer knows, oh, okay, this is the pipe and this is where the water is, or the air is what we're going to use. So once you've created the surface here, you're done with Design Modeler. So now what we're going to do is we're going to move back towards Workbench so that we can see the next step. Okay, so we see back on the workbench, geometry is checked. That's good. That means that we're done with it. Next, what we're going to do is we're going to hit mesh. Now, what the mesh is it determines what points over your region are going to be calculated at. And it'll make more sense once I've actually generated the mesh for you. Okay, so let me move towards the meshing screen. Okay, so this is the new meshing section. Hit Z again so that you can see it right in front of you. Now, we're going to hit mesh here, and you see a lot of options up here. I'll show you two very basic and generic ways to generate a mesh. The first way is you can right-click here. You're going to hover over Insert, and then you're going to hit Method. Now, what this does is it creates an automatic method that will create a mesh for you. So to use the automatic method, after you selected it, you see that you need to select a geometry. Just hit your surface. It becomes green. Hit here and hit Apply. So now you're going to essentially tell the computer, okay, generate a mesh for me over this region, over the blue region. And now just for example's sake, we're going to go here and we're going to hit Generate. And this will generate the mesh based on what you selected. Now this mesh is the worst it can be. You need this to be as fine as possible. And the way that you can help make it better is if you ever want to change the sizing of these spaces here with the automatic method, if you go to mesh, just click here and see element size. By default here, it's 5 meters. So it's only going to compute the fluid's properties every 5 meters. But we don't want that. We want to compute it at many, many, many more points to see the entire flow rather than just the flow here, here, or here. So to make the element size smaller, you just go here and put in a new value. So let's say 0.5. Oh, 0.5. Generate. And then it'll take a second and generate a new mesh. Okay, so you see it. This is a lot better. Now we're taking more points here, here, and here. So now we have more points that we're calculating the fluid's properties over. And so a lot of what meshing is you fiddling around with it, trying to see what will work or what won't. And so one important detail that I do want to show you all is how you can stop a meshing early, because it'll happen a lot where you're going to put in certain parameters. I can say, oh, I'm going to put 0.001, try to generate the mesh, and it's going to take a really long time. And sometimes I think, yeah, this is not going to work out properly. So if you look at the bottom left here, you see this little red button. If you click it, it'll stop the meshing. And here it gives you an error message saying that the meshing was stopped. So if at any point you are using ANSYS and you realize, maybe 10 or 15 minutes your meshing's happening and you don't think your computer is going to be able to generate a mesh in a reasonable time, you can stop the meshing early by pressing that little red button on the bottom left corner. So we'll talk more about the automatic method in future tutorials when we end up using this more. But for this case, I actually found that there's a better way to generate a mesh. So if you ever want to take something out, just right click it, hit delete, and it goes away after you hit yes. Perfect. The second way that you can generate a mesh is you can manually size it. So you can either hit the button up here for sizing, or if you hit right click, insert sizing. What you're going to do here is you're going to select the different faces on the rectangle and tell the computer, okay, this is how many points on that line that I want you to compute over. So the way that you use sizing is first you want to look at these buttons here, and this tells you what region you're selecting. So let's say this is going to be the entire body. So I can select the entire body, but I don't want to do that. This is for a face, still don't want to. An edge, this is what I want to do, because I want to tell the computer, this is how many points on a particular edge I'm going to compute over. So what we're going to do here, after selecting edge, is we're going to hit on one of the lines here, and it becomes green. You selected it. But I don't want to only do the top edge. I want to do the bottom one too. So to do these two simultaneously, you hold down Control, and then you click on the other surface that you want to select. So you see that the top and the bottom side are green because I want them to have the same exact parameters without having to do this twice. So one more time, you hold down Control and you can select all the surfaces that you want to select at once. So what this is for, you're going to select for the geometry, apply. So now it knows, okay, I'm going to look at the sizing for the top and the bottom edges. Then what you want to do is you want to look to here on element size and change this to number of divisions. By default, ANSYS will try to guess at how big you want your divisions to be based on the element size. But as we saw before with the automatic method, ANSYS doesn't really know a very good way to generate the mesh automatically. So by selecting number of divisions, we're going to tell ANSYS, okay, this is how many divisions in the mesh I want over these two surfaces. So we go here as one division. That is not what we want. And on this point, you can play around, say, oh, maybe I want 300 divisions, 250. This is the part where you fiddle around. I found that 450 divisions on this edge is perfect. And you can see how instead of having one giant yellow bar here, we have many smaller ones. And of course, these are not to scale. There are 450 divisions along the lines. Now what we're going to do is we're going to do a separate sizing, because we have told ANSYS, okay, this is how many divisions I want on the top and bottom edges. But now we need to tell ANSYS, what about the side edges here? So we're going to do the same thing as before. We still have edge selected. Up here is a box zoom. So if you press this, just to make it a little bit easier to select this face. So I'm just going to click on this, zoom out, readjust myself. Then I'll actually select here, go back to vertex or the edge, hold down Control, hit this. Now I should have both edges selected, which I do. They're both green. Perfect. Now I'm going to go to geometry, apply, ANSYS knows these are the two edges I'm going to get the sizes for. Same thing as before, changing element size down to number of divisions, and here was 250 divisions. Now to get to these numbers, it's not some calculation that you make. Oh no, it's 200. I'm sorry, 200 divisions. 250 probably could have worked, but it's unnecessary. But what I was going to say now is there isn't something that you plug into your calculator to get it. Sometimes you just play around with it. That's what I was doing before this workshop. I tried out 200, I brought it up to 300, and then I reached 450 and 200 divisions after enough testing. So now we're going to generate the mesh to see what happens. Does anybody have any questions so far about what I've done so far? Am I going too fast, too slow? And feel free to type in chat or unmute yourself if you'd like. Oh, got something in chat. Perfect, alrighty. Yeah, and sometimes the mesh will take a second to generate. So that's why I wanted to take a breather, see if you guys had anything that you wanted to ask me as we wait for the mesh to generate. Hopefully it does it in a reasonable time. Alrighty. Yeah, and it's good to note that sometimes ANSYS does take a second to generate meshes. So yeah. Something else in chat. Oh, okay, that's good. I actually have to use that next strand for my error structures class. So I'll have to see about that. Huh. That's interesting. When I tested it earlier, it did not take this long to generate the mesh. Oh, sorry. I made a mistake. I know why it's taking so long. So you see, I stopped it early because I realized that something's wrong with my meshing. And a very important thing when you're doing edge sizing that I always forget, after you do the number of divisions, you have to look at advanced, behavior, and change soft to hard. Very essential. Never use soft. Soft makes the mesh too weird. And as you saw, it made it load for an unreasonable amount of time. So whenever you do use edge sizing for a situation like this, always change it to hard. And if your meshing is taking too long to actually finish, check that first, because there's a chance that, like me, you forgot to change that parameter. So hopefully now the mesh will actually load. Just make sure. Yep. Yep, they're both correct. Huh. Okay, so again, this is taking too long. This is not going to be the final version of the mesh. What I wanted to show is that the mesh would not have been correct. It would have been rough and all over the place. And I just wanted to demonstrate how it would have looked. So I'm just going to stop it early again to do the final step early, so that hopefully the mesh works. Actually, I'm going to pull the number of divisions down to 400 here. I think it should be okay. And I just want to make sure that the meshing actually happens. But one more thing, that if you do the edge sizing without doing the next step, you'll see what I mean when it's rough. What you have to do is something called face meshing, which all it does is it makes sure that all the lines are straight and in a grid-like pattern. So all you have to do for face meshing is you come here, click on the geometry that you want, apply it, and then it should work. And hopefully, after doing all of this and pulling the number of divisions down, the meshing will not take so long to finish. Yeah, I'm sorry that this part takes so long. It typically does take very long for the, well, sometimes it takes very long for the meshing to generate properly. But when I was testing this before the meeting, it did not take very long. So it just might be a matter of patience. No. Essentially, edge sizing just counts out the number of divisions on the edge. And the face meshing essentially makes sure that you get a grid-like pattern. Because if you just do edge sizing, ANSYS won't always make a grid. It'll sometimes make this really funky pattern with the edges, which is not what we're after. by using face meshing, you ensure that there's a straight, consistent, pattern to the mesh so that you know, oh, okay, this is correct. Yeah, face meshing is just an extra step that you have to do, but usually you only have to do it if you use edge sizing here. Now, I'll probably give the meshing, I have 5 more minutes. It shouldn't take longer than that.
No.
Very good. Alrighty, so what I did, 300 on the top, 150 on the side. Now you see that the mesh has fully generated. Perfect. So I'm going to zoom in to show you what I mean. So after applying the 2 edge sizings and the face mesh, we zoom in really, really close to the element. You can see the grid, right? How the lines go here and onto the side. And what this does is that on each intersection of these points, you're going to compute the properties of the fluid. And when you zoom out, all of the element is black, which means that there's many, many points that you're computing on, which is exactly what we're looking for. So now that we have our mesh finally generated, we can do one more important step. Before you move on, you need to select each section and give it a name. And I'll show you why you have to name all of your sections in a second. So the way that you're going to name each surface, you're going to go back to edge as we've liked before, select the edge that you want to name, right click and create a named section. And the naming is very, very important to the next step. That front line, we're going to call it the inlet. And ANSYS actually knows what an inlet is. So that's why we want to name this the inlet. Next, we're going to select the back end here. And we are going to name this the outlet. Very good. Now I'm going to just select both of the walls here by holding down Control and selecting both of them. Right click, create named section, and call them wall. I grouped them together because there's no reason for me to have them individually. But if I really wanted to, I could have named the bottom wall, and the top wall. But the more important sections are the inlet and the outlet. And then everything else, just label them as walls. So once you've created all of your named sections, you have finished your mesh and you're ready to move on to the next step. So I'm going to go back to the workbench to show you what you have to do. Okay, so we're back here after completing the mesh. Before you hit anything else, you have to go to mesh, right click, and hit update here. This will tell ANSYS that my mesh is done, I'm ready to go, and now I'm ready to set it up. So we're going to go to the setup window, and now I'm going to change the screen share again so that you can see what I'm doing. Oh, share screen, please. Then I need to go here. Alrighty, once you have hit setup, you'll see this, the Fluent launcher. What you'll want to do is hit double precision right here. What this does is it essentially doubles the number of decimal places that the computer will use when calculating, and it's very important to get more precise answers. Everything else is okay. So you're going to hit start. And then we're going to give ANSYS a second to start it up. There we go. I'm going to start sharing it now. Okay. So now you're going to see this window. And it's still loading up. I'll explain it now. What this is, okay, this is finished now. This is where you set up all of your conditions. So what the fluid's properties are, what models are you going to use to model the fluid flow, and also any, like, say, the velocity of the fluid, its viscosity, density. And I'll be changing all of those things so that you know how to change the properties of the fluid to match what you need. So first thing you're going to want to do, you're going to want to go to models here. And you see a bunch of models. So there's like energy if you need temperature or, other things. But the most important model is this one, the viscous one. You're going to double click it. And do you see the viscous model window, or do I have to reshare my screen?
No, we see it.
We see it? Okay, cool. So these are the different models that can model out the fluid's flow. We are going to explore K epsilon in future lessons when we talk about turbulent flow. But for now, we don't really want to worry about that. So we're going to hit laminar here. Now, just an explanation of what these different models are. Inviscid means that there are no viscous forces involved. So the flow will just go forward, and there won't be any, there won't be turbulence. You know, the flow will always be straight along the pipe. Laminar and turbulent, the best way to picture it in a simple way is if you look at a lit candle, the smoke going out towards the flame, the smoke is very straight. That is a laminar flow. And then at the top, it starts to swirl around in a very chaotic pattern that's hard to predict. That's turbulent flow. So for this case, we are just going to generate a laminar flow. So once you've selected laminar, you hit OK. And that is all you need for models. Next up, we're going to go to materials. This is where you select what material is actually going to be flowing into the pipe. I don't know why they're solid here, but don't worry about that. Worry about the fluid side. So you see that we have air. Okay, so air is flowing inside. What can we do? If we double click air, we can see all of the properties of the air that's being inside. So we can see that there's the density, there's the viscosity. Now, we're going to be changing these two things. Leaving it default won't necessarily net the proper result. And I'll explain why right now. Let me open up Paint so that I can visualize this for you properly. Let me go back. Ooh, stop the share. The reason why we need to change the properties of the air is because of something called the Reynolds number, RE. Have you guys heard of Reynolds number before? Ooh, excuse my bad handwriting. I'm using a mouse. Ooh, got something in the chat. Yes, good. So you know that the Reynolds number essentially equates the density, viscosity, and velocity of the fluid. And it tells you if it's going to be a laminar flow or a turbulent flow. So the equation goes something like this. You have the density times the velocity, and you have it's the hydraulic diameter, right? That's what it's called. I believe it should be that. In essence, what this part is you remember the pipe that we made. This just goes on for 100 meters. This part, this diameter, is just going to be the length here, this height, which we made 1 meter. So we're going to put 1 meter for, oh, sorry, before I do that, all this is divided by the viscosity mu. So for a laminar flow, your Reynolds number, oh, wow. Hold on. Forget about that. Your Reynolds number here has to be less than or equal to 2100. This will produce a laminar flow. If it is greater than or equal to 4,500, or is it just 4,000?
4,000.
4,000, okay. If it's greater than or equal to 4,000, in the case of a pipe anyways, you will get a turbulent flow. Anything in between will be considered a transition, which just is sort of in the middle between laminar and turbulent. But since we want a laminar flow, we want to make our Reynolds number less than 2,100. So the way that I did it is I'm going to make this density equal to 1. I'm going to make the velocity 1 meter per second. And I'm going to select the 1 meter here. This way, all we need this to be is 0.001. Because 1 divided by 0.001 is 1,000, right? Yeah. Yes. So, does anyone have any questions about Reynolds number and its implications on the flow? All right, I'm going to continue the lesson. Oh. Characteristic length, thank you. Perfect, it's characteristic length. Sorry, it's been a while. I know that hydraulic diameter is discussed at some point in fluids, but I think I might have confused it for this equation. But characteristic length is a very good descriptor of it. Anyways, back to this. As I said before, I want the density to be 1, the viscosity down here to be 0.001. After we do this, we're going to hit change/create. This will save these new properties of air that the computer will compute with. So now the materials are done. Now we're going to go to boundary conditions. This is why we needed to name the inlet and the outlet, because ANSYS knows that the inlet here is the front face right here. So we're going to double click inlet. And now we can see the changes that we can make to it. So it's already selected to velocity. Reference frame can be left to absolute. All we need to do is change the magnitude to 1 meter per second. And then this should be all that we need to allow the viscosity to be at 1000 to produce a nice laminar flow. For the boundary conditions, this is the only thing you need to change. Usually you can leave the outlet alone. I've never had to change the conditions for the outlet, just the inlet is all we need. Okay, so now we have changed the air, we have the right model, and our boundary conditions are set. What we're going to do is we're going to hit reference values here. We're going to take this and we're going to do inlet. This makes sure that it accounts for the velocity at the inlet and the changes that we made to the properties of the air, like the viscosity here. This isn't totally necessary, but I like to do it just to ensure that the computer knows exactly what we're trying to use. So after we set our reference values, we can go all the way down and hit initialization. And then, oh, something in the chat. I missed the first 20 minutes. Yes, this will be posted in a recording afterwards. Okay. So when you're initializing, just keep it at hybrid. This is totally fine. You hit initialize, and you get a bunch of random numbers. Don't worry about what these are. This is just the computer getting ready. Anytime you are trying to make calculations in this step, you have to initialize first. Even if I'm like, oh no, I made a mistake. I need to change the, the velocity at the inlet or the air's materials. Any changes that I make, I have to initialize again. The other thing is that if this is all zeros, something is horribly wrong. You need numbers here other than just 0, 0, 0. So after we make sure that this is correct, we can go to run calculation, set the number of iterations to, I don't know, 500 is what I usually do, or you can do 1000. The computer will not necessarily go to this length. This is essentially the maximum number of iterations the computer will go to. And if the computer goes at this point, it'll say, okay, we're not reaching a solution. I'm just going to stop now so that you don't end up in an infinite loop. So after you set this, you don't need to change anything else. Hit calculate, and the computer will start making its calculations based on the inputs they have. And you can see this is the number of iterations. Oh, sorry about that. Okay, I'm just going to leave that there. Oh, it's done. So this is the number of iterations that it took. It took, what is this? Maybe 37, 38 iterations, which is really good. And what you want is these lines to go down. So you see how the axis is going smaller and smaller, 1e to the negative 8. If this is going down, this means that your solutions are converging to the right solution. If these are going up, this means that the solutions are going further away from the actual solution, and that's bad. So you want to make sure that at any point, these are all converging. This is a question of modeling methods, actually, how the computer makes these calculations and makes sure that the calculations are accurate enough. But we're not going to go too far into that right now for this tutorial. But if you do have questions, do let me know. So this is done. Now I can stop sharing the screen, go back to the workbench. Here it is. Perfect. Alrighty. Now the setup is complete. Solution, you don't have to use this. It's just a different way to interpret the results. We're going to go to results here. Double click it, and it's going to open up a new window. Now I'm going to stop sharing the screen. It's going to load up. And then we're going to go to the post section. Perfect. So now this is the final part. This is where you get to see the fruits of your labor. You're going to hit the Z-axis here. And now you have a bunch of options to actually look at the flow. My favorite way is to go up to the top left, and this little button is contour. It's the second one to the right of location here. You hit contour. You just press OK, or if you want to name the contour something special, you can. Go to locations, hit symmetry 1. This will select the rectangular region here, or the region of whatever shape you have created. We're going to change the variable to velocity, but you can choose any one of these and actually see what the properties of the fluid are at particular locations. Change the number of contours to 50, and then you hit apply. Perfect. So now we can actually see what the flow looks like. I will turn off the legend just to let you guys see this better. And so now you can see that we have a flow. What I will do, I need to move the top part a little bit. If you hit this here, this is the pan, so that we can move this around. I'm going to zoom in. And then we can actually look at the flow and see how at the start, it starts out a little bit slower, but then as it goes along, it starts to speed up. So just a really quick explanation of what's happening. There's two things I'd like to explain to you. First of all, there's something called the no slip condition. This means that on a surface, so say on this wall here, the velocity of the fluid is the same velocity of that surface. So let's say this is a pipe and the pipe is not moving at all. The velocity of the fluid that is touching the pipe is 0. If the pipe were moving, or if it were, say, a plate that were moving, then the velocity on the surface would be the same as whatever object it is contacting with. The second thing is the boundary layer. And we can see it sort of developing. It starts off with nothing, and then you see this part where the fluid kind of starts to get up closer as it speeds along this layer here. This layer is moving slower because it is within the boundary layer. And let me go back to paint so that I can help you visualize this. And by the way, this is kind of what Osbey, or Dr. Osbey, I would like to be respectful, kind of does in his classes, just so for a primer. Let me resize this to say 500, just so I can have plenty of space. Okay. Oh, I don't know why I am zoomed in so much. That doesn't matter. Okay. So we have our pipe, right? What's happening is that as the flow is going inwards like this, there's going to be two parts here that are the boundary layers. And so you're going to have some velocity, u. The velocity at the edge of the boundary layer is essentially u times 0.99. And the reason why the boundary layer is so important is because within the boundary layer here, there's viscous forces. And that's why that area is slower. But outside of the boundary layer, there are no viscous forces. And so what's happening is that as the flow goes along, the boundary layer is developing and is getting a little bit larger. And then there comes a point where the boundary layers are essentially fully developed, let's say here. And what's happening is that these two boundary layers are acting kind of like a funnel. All the fluid in the center here is sort of being forced into this smaller section here, and it actually increases in velocity until it is fully developed. And then the flow in the center is much larger. So if we go back to the post section, we can see that here. At the start, the boundary layers have not really developed that much. So we have this slower velocity, but as we go along the pipe, the boundary layers are getting larger. They're developing. And as it goes from white to orange to red, that indicates that the velocity is increasing. And if we go along, you can see that these are the boundary layers in the pipe here, and the center is getting much, much faster until around this point where it fully develops and the center here is reaching its maximum velocity. If we pull back the legend here, we can see that at the center, the fluid is actually moving at around 1.5 meters per second when the flow was originally going at 1 meter per second. So that's essentially what ANSYS does, and that's how you use it. Some of the other things you can do, if we take this down, you can make, say, vectors. If you just select vectors, locations over symmetry 1, always do it over symmetry 1. I don't think we really need to change anything else. If we zoom in enough, we can actually see the little arrows here that show the actual flow. And then one more thing that I'd like to show you before we're done is streamlines. So we can start from the inlet, and what the computer is going to do is it's going to create lines that say, oh, okay, this is what the flow looks like, and just create a bunch of lines all over the place. So if we apply it, then we zoom in, you can see the lines. And the streamlines are particularly handy to see the direction of the fluid. So you can see how it kind of starts to go inward just ever so slightly. And you can see that the flow in the center is red here to indicate that it is a much, much faster flow. So this is what I wanted to show you guys. And when you're trying to use ANSYS, you use these basic steps. In future tutorials, we'll show you more advanced techniques, how to use the automatic method more effectively, and just different scenarios so that you can get more familiar with how the program plays out and how it feels. Does anyone have questions for me? Because if not, then this is the entirety of the tutorial that I wanted to show. Chat. Nope. Alrighty. Yeah, that'll conclude this day's tutorial. I'm sorry that the meshing was so rough. I'll make sure to to prepare the mesh ahead of time. And also, I do now understand that Zoom does limit my computer's capabilities, apparently. It eats up memory. And so I'll make sure that next time we don't have to wait so long for the mesh to occur. So yeah, make sure that if you guys would like to follow along with the tutorials, download ANSYS. I showed you how to do that earlier. It's a fairly simple download. Make sure that you have good internet. If you live on campus, you might want to do that at, say, your parents' house. But other than that, if you want to follow along or if you want to try it yourself and something goes wrong, you can always ask me and we can sit down and work on it. But otherwise, thank you guys for coming. It's been fun.
Hey, thank you so much.
Yeah, of course. I'll stop the recording now.